So would these modifications continue to expand within a population, and has any thought been put towards how this could be like self-limited, or would it be expected to continue and basically take over the population, the edited versions?
Yeah, so the work that I presented is on engineering just the Y chromosome in such a way that the Y chromosome isn't selected for or against. And so in order to have it persist in a population, you have to continually introduce more engineered males. If you've heard of techniques such as gene drives are methods where you use CRISPR to affect the inheritance of a particular trait. So it goes from being 50% chance to more than 50% chance. In those cases, those systems are not self-limiting and have proven in dynamic in simulations to be very invasive. So the reason we chose to use the approaches that we depicted, engineering the Y chromosome, is because they are self-limiting.
What would you say are some of the similarities or differences between like cats and dogs being spayed and neutered versus what your theories are?
Sure. So spaying and neutering cats and dogs involves a surgery on an individual animal. The techniques that we have and are developing right now don't require us to find every individual animal in order to effect a change. So it might be easier to implement than it would be, say, for example, control mitigation strategies that look like providing, say, birth control to different wild animals becomes a problem when trying to catch as many wild animals as possible to give them the intervention. And that might be cost intensive and time intensive.
I'm sure a lot of species depend on eating mice and rats, and so I don't know what's going to happen to those species if all of a sudden the rat population goes, let's say to zero.
Yeah, that's a good point. Every species is an island. We all exist in an interweb of connections between one another. And I think it's very important to use, and thinking about genetic control strategies, systems that are self-limited, because we don't know ultimately what the impacts of removing a single species are from an ecosystem until it does, three of which are responsible for the majority of vector-borne diseases, and it's not the entire ecosystem.
Sorry, I'm legally blind. Sorry. So we're just point to the name. Eckelhofer. Yes. Yes. Okay. You got the email. Yes, I did. Yes. Do I need to do anything or no? Okay. All right. Thank you.
So there is certainly a lot of behavior that an organism then get the genetic edit or the genetic system that they gain from the other organism. It's highly unlikely to be the case. The eaglet example, that can pose a serious danger to other organisms in the food chain.
So both these modalities that you discussed involve germline mutations in rodents. And rodents are a big model organism in human research. What's to say that some other lab wouldn't take this research and run away with it in